is how do we work out a rule for a sequence? So what you all need to do now, you've got the questions in front of you, but you need to put your device to one side, so you're just, unless you're typing it, of course, you're just writing this down. So what we're going to look at is a very basic sequence. So we've got an arithmetic sequence. We need to know what that is. Another name for an arithmetic sequence is a linear sequence. Are you writing down, Javier? Because you can put your device to one side just so you're not tempted. Linear. What this means is if I write an arithmetic sequence now, I could start with any number. Give me a number to start with. 6, okay? And I'm going to create a sequence starting at 6, and I'm going to say it is 6, then 8, then 10. What would it be next? 12, then 14, and so on. A linear sequence or an arithmetic sequence has what we call a common difference. And we give it a letter D. And the common difference is what we add on every time. And it's common because it's always adding the same amount on every time. Simple. So in this case, D is 2. If I asked for a different arithmetic sequence, let's say we start at 4 and D was 7, what would the sequence be? 4 followed by
11, 18, 25.
Okay. These would be terms, right? So we have currently 5 terms in this sequence. Right, so what's a term in a sequence? Sam?
Like the answer of the number.
So just the number. So if I asked you, Alfie, what's the third term in the first sequence in red?
Third.
Yeah.
Wait, in the second one?
The first one, in the red one.
It would be 10.
It would be 10, yeah. The third term is 10, yeah. What's the fifth term, Max, of the red one?
14.
Matteo, what's the second term of the second sequence in blue?
The second, 11.
Okay. All right. So we have the first term, second, computer's going slow. This would be the fourth, first, and so on, right? What we're going to look at is how do we write what's called a general rule. And what we want that for is if I said to you, come on computer, why is it going slow? What is the 101st term in each sequence? Computer is struggling. So I'm going to let you have a think about that. How would you work it out? What would be the 101st term in both of those sequences? Feel free to discuss, work it out. What do you think? I'm going to run with your answer a little bit. So with this first one, do we think the 101st term, well, how many lots of +2 do we need to do to get to the 101st term? You with me, Matteo? You look zoned. You with me?
Yes, sir.
Yeah.
What was the question, sir?
How many lots of 100 and, how many lots of 2 do we need to add on to get to the 101st term?
101.
101, you think?
Or you could
Yeah.
take, or you could take,
That's the terms.
so you'd have to take 90.
So I need 101 terms, but do I need to...
90. You take 5.
So let me put it a different way. So the first number of the sequence is 6. Okay? I'm going to do it like this. So the first number is 6, the second number, the third number, the fourth number, and so on. Well, the first number is 6, the second number is 6 plus 2, yeah? The third number is 6 plus 2 plus another 2. That's 6 plus 2 plus 2 plus another 2. Okay. So if I wanted, so what have we got then? So the first number is just 6, but the second number is 6 plus 6 plus 1 times 2. The third number is 6 plus 2 times 2. The fourth number is 6 plus 3 times 2. So what would be the 101st number? It's going to be 6 plus 2, which is what you were saying. Too many 2's. But how many 2's would it actually be? It would be 6 plus. So it would be 100 times 2. Why 100 and not 101? Because the first term doesn't have a plus 2 to be added. So what is the 101st term of that sequence?
Oh wait, no. 6.
100 lots of 2, 200, plus 6, 206. So the 101st term is 206. What is the 101st term? This one then. Why? Well, can we use the similar approach? So it's going to be adding on 7 every time. How many lots of 7 do I need to go? 100. So it's going to be 100 lots of 7 added on to 4. So the answer is going to be actually 704, not 711.
Oh, that's the first answer I got. And then you told me it was 711.
Okay? Making sense? Sort of? Everyone seems to be a bit low. Not, yeah, whether I'm making any headways or not. So let's have a look then at, I'm going to get you to do one more, because obviously it's important in your notes. Let's do that. Yes, I did. All right. I'm going to give you another sequence. I'm going to ask you for the term that I want. So this sequence is going to be, let's do 2 and then I'm going to go for 11. The next number will be 20. Next number will be 29, and so on. I want to know, please, what the 323rd term is, please. What's the 323rd term in that sequence? Write it down in your book. Once you've done that, we'll discuss your answers. So what's our method? We first need to work out the D, which is
9.
plus 9 every time. Okay, so D is 9. So the 323rd term would be 2 plus, how many lots of 9 is it going to be?
322. No.
So it's one less, isn't it, than,
322.
so it's going to be 322 lots of 9. So if we do that, can you just confirm what you get? 2,900. Just to finish us off then, before we go, I'm going to introduce you to the nth term. Another name is the general rule. Last thing we'll write down. Make sure you're writing it down today. Now, based on everything we've just done, there were some common approaches, which was, what was this number?
The first.
It's the first term. So I'm going to call the first term, I'm going to give it a letter so that we know it's always the first term. It's supposed to be writing now. I'm going to give it a letter. Now we have a consistent approach. So the letter we use is actually A. So my general rule is going to be A plus, okay? What was the 9? Well, that's a D. So we're going to have times D. So this is the important bit here. How did I get that number?
Oh, you minus 1, you took away 1.
So it was the term number minus 1. So we're going to use a letter for term number. Any ideas?
B.
N.
Boy.
N stands for the term number. So we're going to have N minus 1 times D. Okay. So we've got first term A, D is the common difference, and we can write it out in a general rule like that, which next time I see you, we'll look at how that looks like the stuff on the page that I gave you to work on for next time. All right.